Welcome to the course which name is Strength of Materials. In this video, I will answer following questions. What is strength of materials or mechanics of materials? What topics does this course cover? And what will the students be able to on successful completion of this course? Needless to say, Strength of Materials is one of the most useful courses in engineering technology education. It is the foundation for advanced structures courses in construction engineering technology and the foundation for machine elements in mechanical engineering technology. The strength of a material is its ability to resist external forces without breaking. In strength of materials, we keep the assumption of bodies in equilibrium, but we drop the rigid assumption. Real cables scratch under tension. Real floor joists bend when you walk across a wood floor, and real axle shafts twist under torsional load. The field of strength of materials typically refers to various methods of calculating the stresses and strains in structural members, such as beams, columns, and shafts. The methods employed to predict the response of a structure under loading and its susceptibility to various failure modes takes into account the properties of the material, such as its yield strength, ultimate strength, Young's modulus, and Poisson ratio. In addition, the mechanical elements' macroscopic properties, geometric properties, such as its length, width, thickness, boundary constraints, and abrupt changes in geometry, such as holes, are considered. On balance, the course covers material behavior, stresses, strains, and deformations with simple applications in engineering designs. For instance, there are following topics: elastic and elastic plastic behavior, plane stress and strain, constitutive relationships, principal stress and strain, failure criteria, bending and shearing stresses in beams, Morse circle, deflections of beams, Eller buckling, short and long columns, torsion of solid and hollow circular sections, introduction to statistical indeterminacy and simple redundant structures, work and strain energy concepts, and other. As a matter of fact, a strength of materials is a difficult course because the topics are cumulative and highly interconnected. If you miss an early topic, you will not understand later topics. If you want to be successful in a strength of materials course, you need the following. Firstly, attention to detail. Solve every problem methodically. Make your step-by-step solution easy for the reader to understand, with the final solution at the bottom. Secondly, algebra. Solve every problem algebraically before introducing numbers or units. Next step is unit conversions. In engineering, we introduce the actual units into the equations and add the unit conversions at the end of the equation. The reason is that real objects are dimensioned in more than one unit. And last but not least, strong work ethic. If you copy someone else's homework solutions instead of working them out, you will fail the exams and you will have to repeat the course. The only way to learn this material is by practicing. A good estimate is 10% of the learning occurs in the classroom, and 90% of the learning occurs while you are solving the problems. I'd like to move on course learning outcomes. On successful completion of this course, students will be able to apply the basic laws of mechanics to components and structures, use analytical reasoning to identify issues or problems and evaluate evidence in order to make informed decisions, demonstrate an understanding of the concepts of stress and strain, demonstrate an understanding of the relationships between loads, member forces, and deformations, material stresses and strains in structural members under axial loading, torsion, flexural loading, shear. Demonstrate an understanding of failure under complex stress states in structural members subject to combined loadings. Apply the above understanding to the design and analysis of structural members based on strain and deformation criteria. Graduates will be competent technicians with problem-solving and design skills and have the ability to apply mathematics, science, and modern engineering software to solve mechanical engineering technology problems. Graduates will have strong communication skills and the ability to work successfully in teams in industry. Graduates will demonstrate respect for diversity and knowledge of contemporary professional, societal, ethical, and global issues, and they will engage in lifelong learning. So, in conclusion, I'd like to say about academic honesty. Academic honesty is expected of all students. Any violation of academic integrity is taken extremely seriously. All assignments and projects must be the original work of the student. Plagiarism will not be tolerated. If you find this video useful, don't forget to give it likes and subscribe to my channel.